Hello, it's Mr. Harper. We are going to be talking about today using the unit circle in trigonometric equations to solve various real life situations. So I'm using some examples, or actually some problems from Progress Learning. So you can also use this for Progress Learning, but you can also it's also going to be some questions on the test and some on the test about this. So the first we're going to deal with is we have the London Eye is a large Ferris wheel with an axle height of 75 meters, a radius of 60 meters, and which makes one rotation every 30 minutes. The height h over time t of a seat on the Ferris wheel can be modeled with the equation h of t equals 75 minus 60 cosine parentheses pi over 15t. Assuming that the car begins at the bottom of the wheel, over the course of the 30-minute ride, determine the two values of t for which h of t equals 45 meters. Now, to do that, what we have to do is we have to have our unit circle handy. So I hope that you have your unit circle, as I outlined in class, what you need to have with you. All right, so what I'm going to do is I'm going to switch to another app to actually work out the problem. Okay? So give me 1 second. All right. Sorry, wrong thing, sorry. Apologize for that. Sorry. Yeah, I need to get to my app. I'm going to find it now, I'm sorry. There we go. Sorry about that. So the rest of the video should go a lot clearer, or be a lot more. Yeah. All right, so we're going to start off with our equation. So we were told that h of t was 45. All right, we were given the rest of the equation, which was 75 minus 60 cosine pi over 15 t. Now on the test, you'll see either a radian or you'll see the degree. So to solve this, first of all, we want to get our cosine by itself. Well, we're going to keep the information in parentheses, but we want to get rid of any numbers that are either in front of or being added to or subtracted from it. So the first thing we want to do is we're going to take this 75, since it's a positive 75, we're going to subtract 75 from both sides. Because remember, we want the equation to stay equivalent. Well, 45 minus 75 is 30. And then 75 minus 75, that cancels, leaving us negative 60, sorry, negative 30, I apologize for that, cosine pi over 15 t. All right. So remember I said we can't have anything in front of the cosine. We can have something behind it as long as it's not being added or subtracted from it. But we can not have anything in the front. So we're going to divide by negative 60 because that'll get rid of that. So when you get to this part, make sure, I know it may be tempted to leave it as a decimal, but remember the unit circle, we don't have decimals. We have just we have whole number, we have fractions, whole numbers, and some expressions with radical signs in them. In this case, negative 30 divided by negative 60 gives us positive 1/2. All right, and then these cancel over here, leaving us cosine pi over 15 t. All right, so this is where the unit circle is going to come in handy. We want to take our cosine and we want to find when on the unit circle when it's positive 1/2. So just to keep you from getting dizzy, I'm not going to put a unit circle up. I'll include that with the lesson. So, and you should also have it in your packet that you received in class. All right. So what you're now going to do is look on the unit circle, and you will find that cosine of 1/2, cosine be when the two values where cosine or the first number is 1/2. First one you have is pi over 3, and the second one you have is 5 pi over 3. All right. So now we're going to take this part here and we're going to have it equal, because once we found out the two values of cosine, the cosine goes away because we have our values. So we have pi over 15t on the right side of both equations. And then from there, we're just going to solve for t. So remember that when we're dealing with fractions, or what we're going to later call rational expressions, we have to use the reciprocal when we flip it. So the pi now goes on the bottom, and the 15 goes on top. Okay, we do that on both sides because we want it to stay equivalent. So we're going to do 15, pi and 15. Now, it doesn't matter what order you do. I'm just doing the one on the right first, but you could do the one on the left first. It doesn't matter. All right, so on the right side of this one, the pi's cancel because they're the same term. All right, but when we get in the 15's cancel because they're also the same term. So all we're going to be left with on the right is t. But on the left, our pi's still cancel because they're the same term. However, if we look diagonally, we can either go up and down or diagonally. Well, if we go up and down, 5 and 3, there's no common term other than 1, so we can't do anything with that, no common factor. There is a common factor between 3 and 15, that's 3. So when we divide 3 by 3, we get 1. And with that 15 by 3, we get 5. All right? So then now, all we're going to do is multiply what we have left. So in this case, we're going to multiply 5 and 5. Well, 5 times 5 is 25. Okay? So that's our first value. So let's come over to the left side and do the same thing. Again, we're going to multiply by 15 over pi. Again, on both sides, 15 over pi. All right? Well, again, on the right side, all the 15s, both 15s cancel, both pi's cancel. When we cancel, we're basically just putting the number 1 there because we're dividing. So if pi divided by pi is 1, and 15 divided by 15 by 1 is 1. So again, on the right, we're going to wind up with t. On the left, our pi's still cancel because it's the same term. Anytime we have pi's diagonally or up and down, we can cancel them or cross them out and put a 1 in its place. All right, same with 3 and 15. We've got the same situation we had before. It's going to be 3. 3 goes in itself once. They give us 3. And 3 goes in 15 5 times. So here, we're going to multiply 5 and 1. So we're going to wind up with 5. All right, so for this question, the answers are 5 and 25. Now, later on the test, you will be given a problem where it's asking you to say between two different numbers, between 0 and some maximum number that we're going to use. When you get to that situation, which we should get, when you get to that situation, you want to look and see which number fits in the range. Like, for instance, I'll just show you an example. What if I said 0 is less than t, less than equal to t, which is less than equal to 20? All right? If we have that situation, we know that 5 is the only one that matches because 25 is greater than 20. So we can't use 25. Even though it's mathematically correct, in the context of our problem or what we're asked in the problem, we can only use one of the values. So you'll see that on the test as well. All right? So now we're going to go on to another problem. Let me switch over to another page. Go back to my photos. All right? Next one. We got the same Ferris wheel. This time our equation is it's the same equation. However, this time it's 75 meters is our height. All right, so we're going to go back to that. And this time we're going to say 75 equals 75 minus 60 cosine pi over 15 t. So once you do a couple of these, you'll start to get the pattern and you'll start to realize how to work out these problems because they're essentially worked out the same. Just the numbers and the trig function changes. So again, just like before, we're going to subtract 75 from both sides because we're trying to get our cosine by itself. All right, so that gives us 0 on this side, and this is 0, but we don't have to write it. We're going to put negative 60 cosine pi over 15 t. All right, next thing we want to do is divide by negative 60. And we're going to wind up with 0 equals cosine and then pi over 15 t. So just like before, we're going to look and see on the unit circle when cosine, or the first number in our, if I said second number, I apologize in the early part of the video, but it's the first number of our ordered pair. We're going to look for the two values where cosine is equal to 0. All right, and it's only 2 times the cosine is equal to 0. And again, you could do degrees or radians, but in this case, our problem gave us to us in radians, so we're going to stay with radians. But if it does give it to you in degrees, like on the test, it's going to give it to you in degrees, then you'll do that. So we have this time pi over 2, and then pi over 3 pi over 2, sorry. All right, so again, just like before, we're going to take this part and we're going to put it on the right side of both equations. And the parentheses, I'm just putting the parentheses. Technically, you don't have to put the parentheses, but I'm just putting the parentheses just to put it in. So again, we're going to do the same reciprocal thing. We're going to say 15 over pi on both sides. Okay, so let's start this time. Let's start on the left side of the equation this time. So we know that pi and pi cancel. Okay, so we're done with that. However, if we notice, 3 and 2 don't have a common factor, so we can't do anything with that. 15 and 2 don't have a common factor. So we can't do anything with that. So we're just going to multiply 15 times 3 and get 45. And then technically this is 1, so 2 times 1 is just 2. All right. And then over here, all of our terms cancel because they are the same numbers and symbols. And we're going to wind up with t. Now, on the test, you may see something. You can't put them in decimal form. Just look at your answer choices and see what it's asking for. In this case, we're going to change this to a decimal, which is going to be 45 divided by 2 is 22.5. And that's going to equal t. All right, so let's go and do the other one. So again, 15 over pi. And then 15 over pi. So again, these cancel here on the left. 15 and 2 are not like terms, so we'll say 15 over 2. Over here, everything cancels, leaving us t. All right, so 15 divided by 2 is 7.5. So this time our answers were decimals. Now leave them as decimals. Don't round up unless the question asks you to round up. But in this case, we're going to leave it as 7.5 and 22.2. 22.5, sorry, 22.5. All right. We're going to do one more, and then that will complete our word problems. All right. This time, we're talking about the height of the tide varies between high tide and low tide. Researchers at the Bay have found that the height in meters of its tide, h, over time in hours, can be modeled by the equation h of t equals 3 plus 2 cosine pi over 4 t. All right. So to solve this one, and then asks us to find where the high tide occurs at t0, it finds and says our actual question says find the value of t where h of t equals 3. And this is the one where it has a range, which I'll repeat again, 0, which is less than t, less than equal to t, which is less than equal to 4. Let's go back to our problem. All right. So again, we were told that h of t is 3. Our equation was 3 plus 2 cosine and then pi over 4 t. All right, so again, just like before, we're going to subtract 3 from both sides. We're going to get 0 equals 2 cosine pi over 4 t. Now we're going to divide by 2 and get 0, because when we want our cosine by itself, equals cosine pi over 4 t. Now, just like before, we're still going to look at it and say when cosine is 0, meaning our first number is 0, the two places it happens at is pi over 2, and just like before, 3 pi over 2. All right, so again, we're going to take this part here, and that's what we're going to put on the right side of our equations. Sorry for my sloppy handwriting, if it's not legible. All right, so we're going to start on the left side this time. So again, our reciprocal of pi over 4 is going to be 4 over pi. And we're going to multiply both sides by 4 over pi. All right, so everything cancels just like before because these are the same numbers. And we're going to be left with t on the right side. On the left side, our pi's cancel, and then we look at our numbers. Well, 4 and 2, the common factor is 2. So we're going to divide both of them by 2. So 2 by 2 is 1. And 4 divided by 2 is 2. So then, remember, this is a 1 here. So 1 times 2 is 2. So that's our first value. Okay? Then we come over here and do the same thing. Again, 4 over pi. 4 over pi. So again, these cancel because they all become 1. And we got t. Over here, our pi's cancel. And then 3 and 2 don't have any like term, don't have any common factors. However, 4 and 2 do again. So 2 divided by 2 is 1, and 4 divided by 2 is 2. So now we're going to multiply 2 times 3 and get 6. All right? So just like before, we got two answers. However, we were given the range, or the range of values, where 0 is less than or equal to t, which is less than or equal to 4. So if we look at our two values, only one of them is between 0 and 4, and it's this one here. So that's going to be our answer. T is going to be equal to 2, or 2 equals t. All right? So those three equations, like I said, for the rest of progress learning and for the three problems we're going to have on the test, excuse me, like this, they're all going to be the same. You're going to be given a value, and you're going to set up the problem, and you're going to solve it based on what trig ratio, what trigonometric function is being asked for. All right? So I'll talk to you in the next one. So again, use these example problems, which actually are 3 problems from progress learning. So you have the answers for 3 problems of progress learning, 6.2. So you would just finish out the rest using the same process. So I hope you wrote these notes down, and I will talk to you in the next video.